Picture this: a lone object streaking through the cosmic void, defying every law of physics we thought we knew. In October 2017, astronomers caught sight of something extraordinary, a visitor from beyond our solar system, unlike any asteroid or comet ever seen. They named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. Fast forward to 2025, and new data has turned this mystery into a heart-pounding enigma. Renowned physicist Michio Kaku just dropped a bombshell. Oumuamua's bizarre behavior suggests it might not be a natural object at all. Could this be humanity's first glimpse of alien technology, or is something even more mind-bending at play? Buckle up, because this cosmic tale is about to take you on a wild ride that'll leave you questioning our place in the universe. Let's rewind to October 19, 2017, when the Pan-STARRS telescope in Hawaii spotted something unprecedented. This wasn't just another space rock. It was an interstellar interloper, the first object ever confirmed to originate outside our solar system. Oumuamua was bizarre from the start. Cigar-shaped, roughly 400 meters long but only 40 meters wide, like a cosmic needle tumbling through space. Imagine something 10 times longer than it is wide. Nothing like the lumpy asteroids or icy comets we're used to. But its shape was just the opening act of a cosmic mystery. As it swung past our sun, Oumuamua refused to play by the rules. It showed no signs of being a comet, no evaporating ice, no gas or dust tail, no heat signature. Then, in a twist that left scientists speechless, it sped up. Without any visible propulsion, without ejecting material, Oumuamua accelerated as it moved away from the sun. This wasn't just odd, it was physically impossible by everything we know about space. What was this thing, and why was it breaking all the rules? In 2025, a team led by Michio Kaku and other top astrophysicists used cutting-edge quantum-enhanced optical modeling to reanalyze Oumuamua's trajectory, and what they found is straight out of a sci-fi blockbuster. The acceleration wasn't random, like you'd expect from a natural object pushed by solar winds or gravity. Instead, it followed a precise mathematical pattern, perfectly synchronized with Oumuamua's 7.3-hour rotation cycle. For every spin, its acceleration adjusted by exactly the right amount to maintain a stable course. Asteroids don't do this. Comets don't tweak their paths with such precision. Even more astonishing, the data revealed microscopic variations in acceleration that matched theoretical models for advanced light sail technology, a propulsion system that harnesses stellar radiation to glide through space. Kaku describes it as responsive surface geometry, a surface that dynamically adapts to maintain stability, something we've only begun to explore in theoretical physics. This isn't the work of cosmic chance. It's the hallmark of design. Could Oumuamua be a silent, efficient probe, drifting purposefully through the galaxy? But the plot thickens when you trace where Oumuamua came from. Using the European Space Agency's Gaia mission, which mapped over 1.8 billion stars with unprecedented precision, astronomers traced its path backward. The result? It hailed from a region known as the local standard of rest, a quiet pocket of space with no binary star systems, no massive stars, no supernova, nothing that could naturally catapult an object to interstellar speeds. Scientists call this a gravitational dead zone, a cosmic backwater where objects should remain undisturbed. Yet, Oumuamua came roaring out of this void, defying every natural explanation. If it wasn't launched by stellar forces, was it placed there deliberately, in a region where its departure would go unnoticed? The idea is chilling. A perfect hiding spot for something meant to slip through the galaxy undetected. What if Oumuamua was designed to avoid drawing attention to its origin, quietly drifting until it reached our solar system? Then there's the rotation, and this is where things get downright eerie. At first, Oumuamua's tumbling seemed like the chaotic spin of a jagged space rock, but in March 2025, Advanced deep learning algorithms peeled back the layers, revealing something astonishing. Its 7.3-hour rotation cycle was precise, with a variance of less than 0.002%, a stability impossible for a natural object drifting for millennia. Superimposed on this were microtational adjustments every 43.8 minutes, systematically exposing different surface areas to solar radiation. This wasn't random tumbling. It was a programmed pattern, like a spacecraft scanning its surroundings or optimizing energy collection. Engineers see this in our own satellites. Controlled rotation ensures thermal regulation and solar panel efficiency. Oumuamua's spin suggests it was designed for multiple purposes, harvesting stellar energy, surveying its environment, or even broadcasting signals in all directions. Was it quietly studying our solar system as it passed through, like a cosmic spy? Perhaps the most perplexing clue is the thermal signature paradox. When the Spitzer Space Telescope trained its infrared detectors on Oumuamua in November 2017, it expected a clear heat signature. The object passed within 0.25 astronomical units of the Sun, closer than Mercury, where surface temperatures should have soared past 500 degrees, 260 degrees C. Yet Spitzer saw nothing. No infrared emissions, no heat, despite absorbing solar radiation. In 2025, enhanced thermal mapping algorithms confirmed this anomaly. Oumuamua absorbed energy without re-emitting it, defying the basic laws of thermodynamics. There are only three possibilities, each more unsettling than the last. First, it could be made of an unknown material with impossible insulation properties, far beyond anything found in nature. Second, it might use metamaterials, engineered structures that manipulate radiation in ways we're only beginning to understand. Third, and most chilling, it could employ intentional thermal cloaking, a stealth technology designed to hide its heat signature. NASA's researching similar concepts, but nothing this advanced. Was Oumuamua built to slip through our system unseen, only caught by a stroke of luck? This leads to a radical theory from Kaku and Harvard's Avi Loeb. Oumuamua might be a technological relic, not an active probe, but the remnants of one. Its shape, 400 meters long, 40 meters wide, resembles a communications array or a damaged light sail, not a natural rock. Its tumbling, once thought chaotic, suggests a degraded system still following fragments of its original programming. The lack of active transmissions supports this. It's silent, like a derelict ship adrift for eons. This aligns with the litter hypothesis, a solution to the Fermi paradox, which asks why we haven't seen alien civilizations despite their likely existence. The hypothesis suggests we'll first find alien tech as cosmic debris, not deliberate signals. But Kaku raises a darker possibility. What if Oumuamua was a dormant probe that already completed its mission? Its path took it through the information-rich inner solar system, close enough to scan Earth without being too obvious. If it was collecting data, our atmosphere, our broadcasts, our tech, it's long gone, and whatever it learned is already out there, transmitted to an unknown recipient. Now, let's dive into the most unsettling idea: Kaku's passive probe theory. Oumuamua's trajectory was perfect for reconnaissance, skimming within 0.25 astronomical units of Earth, close enough to capture our radio, TV, and internet signals for about 72 hours while staying just out of reach. Its thermal invisibility, precise acceleration, and scanning rotation scream stealth observation. A probe like this wouldn't broadcast. It would listen, record, and leave. If it was surveilling us, it could have analyzed our atmosphere for biosignatures, mapped our technological emissions, and studied our culture, all without us noticing. Kaku points to historical parallels. Reconnaissance often precedes contact, and not all contact is peaceful. If Oumuamua was a scout, its makers know far more about us than we do about them. We're left in a vulnerable position, with an asymmetry of information that could spell trouble. What did it see, and who did it tell? Here's where it gets truly alarming. Oumuamua might not be a one-time visitor. Statistical models, based on our limited detection capabilities, suggest one such object passes through our inner solar system every year. We only spotted Oumuamua because it came unusually close, and our telescopes cover just 15% of the sky at the depth needed to detect such objects. Most likely slip by unseen, especially if they're cloaked like Oumuamua. The Vera Rubin Observatory, set to begin full operations in late 2025, could change the game. Its 8.4-meter mirror and 3,200 megapixel camera will scan the entire visible sky every 3 nights, potentially spotting interstellar visitors weeks or months out. This opens the door to interception. Project Lyra, a mission concept from the Initiative for Interstellar Studies, proposes using a Jupiter gravity assist and advanced propulsion, possibly nuclear thermal or solar electric, to chase down such objects. The physics are daunting, requiring 5 to 6 times the velocity change of a Mars mission, but it's feasible. A spacecraft launched within 6 months could catch a target within 2 to 3 years. But what if the next visitor doesn't just pass by? What if it slows down, approaches Earth, or tries to make contact? The evidence is hard to ignore, and it's not based on speculation, but on rigorous analysis from leading institutions. Oumuamua's acceleration matches advanced light sail models, not natural forces. Its origin in a gravitational dead zone defies astrophysical logic. There's no mechanism to eject it naturally from that region. Its thermal invisibility breaks thermodynamic rules, suggesting either unknown materials or deliberate stealth. Its rotation, stable to 0.002%, follows a programmed pattern optimized for scanning and energy collection. Its shape and behavior align with artificial design, not cosmic chance. Kaku and Loeb describe it as a technological signature we can't dismiss. Discovered by chance on October 19, 2017, Oumuamua's name feels prophetic, a messenger from afar. As it speeds away on its hyperbolic trajectory, never to return, it leaves us with questions that shake our understanding of the cosmos. What if Oumuamua was watching us? We'll never know what data it gathered, our technology, our resources, our conflicts, or what conclusions it drew. If it was a probe, its makers could be light years away, analyzing our planet's strategic value. And the most chilling thought, we only detected Oumuamua by luck. How many others have passed through unnoticed, cloaked in thermal invisibility? The statistical models suggest they're frequent, implying a systematic survey of our galactic neighborhood. Kaku warns we should prepare for the next encounter, which might not be a flyby. A direct approach could be coming, and with technology far beyond ours, we'd be powerless to stop it if its intentions aren't friendly. This isn't just a scientific puzzle, it's a wake-up call. Oumuamua has changed how we view our place in the universe. Was it a relic, a probe, or something we can't yet comprehend? Did it study us? And if so, what did it tell its creators? The Vera Rubin Observatory might soon spot more visitors, and Project Lyra could give us a chance to catch one. But each new detection will bring the same question. Are we ready for what comes next? The universe just got a lot stranger, and Oumuamua might be the first hint that we're not alone, or that we've been watched all along. What do you think? Is this proof of alien tech or just a cosmic oddity? Are we on the cusp of a galactic discovery, or facing a mystery we're not prepared to solve? Share your thoughts below, and if this story has you gazing at the stars, hit subscribe and share it with someone who loves a good cosmic mystery. Oumuamua's gone, but its message lingers, and the next visitor might already be on its way.